Hello, everybody, and welcome to the Reuse Company webinars. You will be muted during the webinar, but if you have any questions or comments, you can use the questions section. The webinar will be recorded, and in a few days, we will send you the link to the recording. Today's topic is requirements completeness, how to detect missing information between textual requirements and models. Our presenter today is Elias Josfi. My name is Cecilia Carlson, and I will be hosting the webinar. This is the agenda for today. First, we will have a short introduction to the Reuse Company, and then we will see what requirements completeness is and why it is so important. Next, CES Engineering Studio and the CCC approach, and after that, completeness of sets of requirements. Then we will see completeness of individual requirements, and finally we will see a demonstration, and we will have some time for Q&A. So what do we do in the Reuse Company? The Reuse Company is a tool vendor specialized in the application of semantic technologies and artificial intelligence to improve the digitalization of systems engineering processes. Here is an overview of our tools. We are usually known in the market for our software tools for requirements engineering. You might have heard of RQA, Quality Studio for quality analysis, RAT authoring tool, our writing assistant, KM Knowledge Manager, Traceability Studio, V&V Studio, Rex, it's a requirement engineering tool for MS Word, and our newest product, CES Engineering Studio, which offers connectivity and interoperability between systems engineering tools and technical management processes. Today's presenter is Elias Josfi. He is a senior key account manager at the Reuse Company. He has a master's degree from the University of Montreal and the IMT Atlantic School of Engineering. He has a background in energy and mechanical engineering and has also been involved in research projects. Elias is also passionate about international projects and languages. So let's start. Hello, Elias.
Hello, Cecilia. Hello, everyone. Thank you for the introduction. So let's get going now with the topic of today's webinar, which is requirements completeness. Before we get deeper into the ways we do assess completeness and how to ensure we get it, let's start asking ourselves these two questions. What is requirements completeness? How should we understand it? And also, why is it so important? And then I'll give you some tips and tricks to make sure you reach completeness in a more efficient way. So let's start with this pie chart extracted from the chaos report of the Standish Group in 2018, which is basically giving information about how many software engineering projects succeed, fail, and get challenged in cost and schedule. And we'll see that that's a very striking number, considering that we can have a lot of projects that don't go as expected. And related to completeness, we have to ask ourselves, why are so many projects failing? So that's what the first information we would like to get from this pie chart, and also how to avoid facing situations that could lead to project failure. And we'll see that completeness has a big part in it. So if we look at this table and the pie chart on the right, both are coming from the same chaos report, and we see that on the right, incomplete requirements is within the top 3 reasons why projects fail. And at the same time, we can see on the left why projects succeed. And related to incomplete requirements, we have different reasons why those requirements are not complete. One of them being that we don't involve the users, so we might have a partial understanding of what the needs for the system are. Same for the support of the management. So if we don't have the support for the management, we would also miss some components. And also the other reasons could be impacted by incompleteness. If we look at the definition of what incomplete means, you see that the important word here is necessary. So we might think that just by having an apparently complete set of requirements, we're good. So I'm covering all the system functions, I'm covering all the states, all the situations, wanted and unwanted, that I want from the system. But is the requirement really necessary? Because if I write a set of requirements and only half of them is necessary, then I don't have a complete set. So we'll get to the concept of necessary and the correctness, consistency, completeness approach that we have. And you will get the idea that completeness is just a component of the requirements quality. It's an important one, but it's not the only one. So we presented a webinar about requirements consistency about 2 weeks ago. So that's another component, and correctness, of course, is another aspect. So we get to that later, but the importance here is on the necessary aspect of the completeness. And so if we look at the INCOSE guide to writing requirements, it says that we should sufficiently describe the necessary capabilities, characteristics, constraints, interfaces, so every feature related to the system to understand how it should behave, and also how to meet the expectations from the users and stakeholders. So it should be the minimum and sufficient set. So both at the same time. Don't over specify, but don't miss any valuable information in the system definition. So how is requirements completeness affecting project success? As I said earlier, we have you could have a lack of user or customer acceptance. So if we miss some of the aspects that were expected, then we might end up with a low acceptance of the product. Underestimated project cost and schedule, considering that we don't describe all the functions, all the necessary implementation that would be underlying from the requirements, then we are underestimating the project cost, and also the cost to analyze the requirements, the cost to implement them, the cost to rework on the requirements. So everything will be underestimated because of the fact that we have a partial set of requirements. It could end up to fail development. So the concept of technology illiteracy. So if we don't have sufficient technology definition in the requirements, at least from the expected behavior or functions, then we might end up with a partially functional product. We might end up with unverifiable requirements. So the set of requirements, or what forms the specification, needs to be verifiable. So if we don't have all the requirements, then we might end up with situations in which the system is not verified, and we can end up also with unsafe requirements and systems. And you see here, this is a quote from saying that major system failures and accidents are often caused by missing requirements. So that means missing requirements is a major failure factor and leading to accidents. So not only a failure in terms of project cost and schedule, but also consequences for the surrounding environment. So to be able to get completeness, we should think about different aspects of completeness. So we need a complete requirements repository to get the complete specification. So that's for sure. So considering that we are relying on inputs to assess the completeness, this is how we would do it using the SAS Engineering Studio and the RQA quality management capability. From the inputs we have, so the more inputs we have, the more accurate the completeness check will be. So of course, starting with a very few inputs, it's easy to say I'm complete because I need to cover very few aspects. But as I develop the inputs, so the more knowledge I have, the more difficult, quote unquote, it will be to get completeness. But this completeness assessment will be more accurate. And the same occurs with the requirements repository. The more information I have to be assessed, the better I have in terms of relationship, And also, I need to connect these different requirements. I need to synchronize them to have a consistent set of objects to assess. So we need a complete and synchronized requirements repository, which means that it's not only about having siloed sets of requirements, but we need to have a relationship between them to avoid over specification, to avoid inconsistency. And these two dimensions together can harm the completeness of the whole set. We need also to have a complete data dictionary. So related to the previous slide, the pyramid, starting from the data to the wisdom. So the more information we gather for the dictionary, the more accurate will be the completeness check will be. And we presented a webinar about data dictionaries and their importance in evaluating the quality of the requirements. So if we are missing a source, a potential source of information, then we're missing some inputs that will, in the end, affect the assessment of the completeness. So now let's go back to the INCOSE guide to writing requirements. So we have here the 15 needs and requirements characteristics. We have characteristics of individual requirements. So completeness is one of them here. And we also have the characteristics of sets of requirements. And we also have the completeness characteristic here. So right from this point, we see that we have two different completeness checks. One is at individual level. So is the syntax of the requirement complete? We'll see what this means and how this could be checked in the tool. We also have an example during the demo. And for the completeness of the sets of requirements, this is checking several requirements, and we check against some inputs that will assess how many of those concepts are being covered in the specification. So also an example that we'll see in the demo after the presentation. So overall, in the INCOSE Guide to Writing Requirements version 4, so we see that the completeness, so both for the individual requirements and sets of requirements, is just a part of the rules that are involved, but these have an impact when they're not assessed. So it's important to have them considered. So let's talk about some tips and tricks to reach requirements completeness. So that's what we have on paper. Then we'll see when we distinguish the individual requirements and sets of requirements how this occurs. But these are just general concepts to make sure that right from the start we have the right understanding of what completeness is and how we can ensure that we have complete requirements and requirement sets. So the first consideration is to embrace the system context and involve all stakeholders. We should involve also all the requirement types. So not only describe the functionality, but also describe safety aspects, compliance aspects, performance aspects, etc. We should be concise in defining the requirements. So that's a correctness aspect in that case. But concise doesn't mean that we shouldn't cover all the questions. So we shouldn't reduce the content, the information included in the requirement, just because we need to be concise. So this conciseness and completeness aspects can be facing each other at some point, because we want to be as clear as possible, as have a short sentence, but at the same time, the requirement needs to be self-contained and needs to include a minimum amount of information. So asking the right questions, how, but especially the 5WH, will be giving you a complete structure, and we'll see how this could be expressed in the requirement statement. It's also about what you need the system to do and not do. So requirements should cover should convert the expectations expressed by the stakeholders and future users, but also cover what could happen if we have an unwanted behavior or the use is a misuse of the system. We'll see an example in the next slides. So sunny day versus rainy day. And finally, the communication with stakeholders is very important, because this is what drives the requirements definition. So about the system context, of course, every stakeholder is important, starting from the closest surroundings of the system, and including containing systems and the wider environment. So the stakeholders can be other systems, so interfacing systems. It could be political, social, human systems like governments, agencies, regulators, opponents. So these are also stakeholders for the system. So we should take into account the fact that they will be having influence on the system. The containing system, of course, could be another system. So if you have a system of systems, then this could be another system. It could also be other agencies, governments, national, regional entities. So whatever we could think of. But the idea is to have all these considered to make sure that we don't miss any aspect. So the assessment of who are the stakeholders and the requirements elicitation that will result from that is very important. Considering the different types of requirements here, according to the NASA Systems Engineering Handbook, you see that we have some requirements types covering different aspects of the system definition. So we have technical requirements. So those who are which are mostly where the effort is put. So functional requirements, performance requirements, interface requirements. But we also need to consider operational requirements. Reliability requirements are also very important. Safety is also a big aspect, especially in some standards dedicated to safety and risk. We have here the specialty requirements also that could be involved. So considering that we have different kinds of requirements, it's good to make sure that with this short checklist that we're not missing everything. So that's what NASA Systems Engineering Handbook is providing. It's a good start to know where to go. We can consider these 7 product dimensions. So this is also giving you the scope of what could be a requirement specification. So we can be oriented to users, interfaces, so actions. We see the same top 3 that we had, so to say, in the previous slide. But we also need to consider data storage, data management, control. So any constraint could be compliance, could be regulation, could be related to any internal standard. Here, environment. So again, considering the context of the system, this will have a big impact. And also some quality attributes here, we would be considering operational aspects and performance. And also we shouldn't forget the safety requirements here. So safety is very important. We could consider safety requirements as kind of a control, but it's better to consider it as a separate aspect, especially if you consider some standards which only cover this aspect. So the next tip here is asking the proper questions will help writing high quality requirements. So what rather than how. So what is the main aspect here? This is defining the converting the expectation into design input. The why is important to have mainly in a separate attribute like the rationale. So it helps knowing the intention that was expected, so that was intended at the beginning. So what usually refers to the system of interest, system of systems, entity or interface involved. Who is usually pointing to the stakeholder or user or any human that will interface with the system. What is usually referring to the function as well. So we have 2 what. That's what is a main dimension here in requirements. So what subject, what system is performing the action, and what kind of action if we consider a functional requirement. How much of many is related to the performance or property requirements, so defining, for example, a maximum maximum value for power consumption or weight or any aspect that will define the boundaries for the design. And then while is referring to the state or mode, so in which situation the system is, and then the trigger to the action. So we'll see the consequence of not having these two here in the next slide. So as much as possible, we need to avoid the prevalence of ubiquitous requirements. So ubiquitous requirements is one of the EARS patterns for requirements. So this is just defining a system name shall system response. An example here would be the car shall accelerate from 0 to 100 kilometers per hour in less than 10 seconds. So from here to there, the syntax is okay. The problem is that we don't have any condition. So when should this happen? And that's the problem of ubiquitous requirements. We have some requirements that could be ubiquitous. For example, we want at any moment the system to comply with a standard or to comply with the regulation, but we don't want this to happen anytime. So we need to define conditions. And so that's why ubiquitous requirements is just a subtype of bigger requirements of the EARS patterns. So the easy approach to requirement syntax. For example, patterns, state-driven functionality, event-driven functionality will include this sentence, but they will have a condition before. So one example would be this one. While the gearbox is in drive and the parking brake is not engaged, when the driver steps the gas pedal. So we have a lot of things that need to be complied before the car does this action. So that's not just about functionality, expected functionality. It's about defining the logical condition, the trigger, and the state in which we need this to happen. So it's also important to have in mind the system life cycle. So when is in the life cycle the requirement is being defined. So we have early requirements definition in the development. We have requirements before the production. We have requirements also for the maintenance. So we have different aspects. So depending on when this is happening, we need to ask ourselves the question why, and the why is usually what will answer the question about how necessary the requirement is. So if we don't know why we're writing the requirement, then this might result in finding out that this requirement is not necessary. So the why here is also very important. And also don't forget the transition requirements. So usually the requirement here, this is an open loop, but we like a sequence. But retired systems could also have impacts in newer versions of the same systems or other systems. So don't forget the transition requirements. So this is what we already said about the sunny day versus rainy day. So the idea to avoid focusing just on the happy path. So this is what happens when everything is okay. But what about the pin code having wrong pin code and having more than 3 attempts? This is the unwanted scenario, and we have to cover also what happens in that case. Also cover all the use cases, but also the misuse from a hacker, for example. So what happens if the user doesn't have the expected behavior that we are describing? So we talk about unwanted scenarios. We should think about unwanted stakeholders as well, not just the ones that we think will be having an interest on in the system, but also those who will have a misuse of the system and how to mitigate the risks that result from that. So And finally, the other aspect that we need to have in mind is the communication with the stakeholders. So it's not just about assessing the different stakeholders, but also maintain a good communication with them. So if we apply the principles of neurolinguistic programming, which says that we can basically sum up by saying the map is not the territory. So we actually filter what is said by the stakeholders just by applying these concepts here. So anytime someone is thinking about something and saying something, there's a distortion, light in that case, but the bigger distortion happens when one stakeholder will express a need and another engineer, an engineer will understand this need in using interpretation, good or bad, but at the end we have a different understanding of what's happening. That's where distortion happens. We have also deletion. So some aspects are considered irrelevant. Some subject matter experts could overlook some aspects because it's a no-brainer. Okay, why do we need to express a requirement for that? Because it makes sense. So that's usually something that could lead to incompleteness. So requirement is not something that needs to be complex to be written. Also, the basic cases must be written. So we usually compare what would be requirements with the literature. So the same aspect of repeating the same syntax n times. So it sounds and looks boring, but we need that to make sure that we ensure proper verification, traceability to the other life cycle stages, and so on. So we don't have to consider anything irrelevant. The relevance is not the need for defining this is not the point here. If it's necessary for the system to operate, then we need to have this defined. And so other tips here to improve the communication is also to think that completeness is how we perceive the mandatory needs of stakeholders. So some needs will have a higher priority than others, but if we want to achieve user and stakeholder acceptance, then we need to also consider that everything that is mandatory is to be taken into account. That's why early validation is very important before we end up in a complicated situation in which it's difficult to get to this completeness. So using checklists and templates, we make sure that we cover a minimum in the document structure, in the structure of the single requirement, so what we call patterns or boilerplates. The attributes also belong to the requirement statements, or what forms. So I'm talking here INCOSE guide to writing requirements vocabulary. So what forms the requirements expression is a statement and a set of attributes. So we need these attributes and links also to be defined. Requirements reuse is an important aspect as well. The more reusability we include, the better, the more improved the templates and checklists will be. We need to establish a formal inspection process. So make sure that we have a proper verification of the requirements. So we'll get to that just after with how we can use natural language processing and AI to guide you in assessing the completeness. Then considering the elicitation process as an iterative and recursive process. So these are two properties, very important properties of the processes in the INCOSE System Engineering Handbook. So saying that if we use a waterfall approach in which cascading down requirements considered incomplete, then we cannot go back and say, okay, starting from an incomplete set of needs, we will not get to a complete set of requirements. That's basically what we're saying here. And so using iterative and recursive processes, early validation, feedback loops, then we make sure that even though the first set is not complete, we have a feedback loop to say, okay, we probably have missed something, so we should go back and do a second round to make sure that we don't miss anything. So this could, maybe that's not the only reason why we have such a difference, but could be one of them. But it's good to have these numbers to compare what would be an agile project versus a waterfall project. So Standish Group report, again, from the year 2020, it's mostly tackling software engineering development, but the trend is here, and we see that with agile processes, we reach a higher success, and it's probably for some reasons because we include this iterative and recursive approach. So now let's look at SES and the CCC approach. So CCC stands for correctness, consistency, completeness. So in the SES, which is short for Systems Engineering Suite, we have a different set of components helping automate the measurement of requirements quality, support requirements authoring. So we'll see two of these aspects, these aspects we're seeing here in the demos. And of course, this relies on a data dictionary, what we call the ontology or knowledge base to support the assessment of the quality, among other things. So we can connect to different tools to assess the quality of the requirements, to help writing requirements using a plugin of the authoring tool. We have plugins in the tool interface in desktop applications and also a web browser extension. So you can get more information on our website, or you can just send us an email if you have more questions about this. And if we look at this CCC approach, so as I said, correctness, consistency, completeness, we consider that requirements quality needs to have these three components connected and assessed. Otherwise, it's only a partial assessment. So if we consider that each and every requirement is correct, has a proper syntax, has no vague or forbidden word, but we don't check the completeness, then that's not enough. If we have a correct set of requirements, complete, but some requirements are not consistent because some are duplicates, some are contradictory, we have also difficulty to assess to verify the requirements and test, because we have inconsistent things and we cannot properly implement the system. So we need these three dimensions. The main difference between correctness and the two others is that correctness is evaluating individual requirements. So aspects such as the syntax, the traceability of one single requirement to other assets, the fact that one attribute is empty. So all these aspects individually checked are included in the correctness aspect, including the completeness of the syntax, which is what will come after. But we'll first focus on the completeness of the sets of requirements. So together with consistency, completeness considers the sets of requirements. So we cannot conclude about the completeness of an individual requirement. We need the completeness of the whole specification. So if we check that all the inputs are mentioned in the requirements, then we need to check the whole set. Same for the consistency. To check that we have duplicates, we need to check all the sets of requirements. So the three tools here that you see, two of them will be featured during the demo. The knowledge manager is the back office tool to configure the knowledge inputs. So you can interface with models. You can input your own vocabulary to check then the completeness. But we will not be focusing too much on that. If you have more questions, just let us know. So let's start with the completeness of sets of requirements. So in that case, what we ask ourselves will be, for example, are we covering all the requirement types in the specification? So related to what we saw about the NASA Systems Engineering Handbook types of requirements. Are all the key concepts involved? So considering the ontology that is or not interfaced with models, do we have blocks, states, signals involved? are all the system elements defined in the requirements? Are all the behavior and activities defined in the expected state and mode? Do we have all the messages, signals? Is the signals, are the relationships all mentioned? So anything related to the coverage of concepts will be falling down into this category. For example, here, very simple example, we have a set of requirements, just a small specification of 5 requirements. Anytime one word will appear, it will be counted as an occurrence, and then that's how we assess the completeness in a very simple case. So you can imagine that this could be applied to thousands and thousands of requirements, considering 4, 5, 10, 20 models involved together. So in that case, I just have a small logical architecture and a small set of requirements, but it's just to illustrate what we could do. So one way would be to check the occurrence of the term. We can also check the occurrence of a relationship, considering that this sentence structure is introducing a relationship, composition relationship between 2 elements. Instead of just assessing this and tick the box with each individual element in the model, we could also tick the box in the relationship here. As we can see for the states here, for example, we detect each state individually, but we can also detect that we find ourselves in a state. We have transition to another state, and we could detect that we are having this occurrence of the transition. So not just the nodes, but also the relationships. Okay, so here that's how we would assess the completeness. So in the tool, this would result in 3 different metrics. One is checking how many of the states we have. So here we would have 5 out of 6. The other one would be checking the number of transitions. So this one is not represented, but if we don't have any transition described from start to authentication, then this is one missing as well. And the same for the functions here. So this would be, for example, a very incomplete, quite incomplete set of requirements. So looking now at the individual requirements. So what does individual completeness means? It means that we actually check the syntax and make sure that we don't have any missing aspects. So that's related to the WH questions. So do we have the system responsible for the action? When is the system finding itself? Which state? Under what conditions? How fast? How well? Performance, time constraint, etc. And for what actor? So interface with the surrounding environment. In that case, action X shall be done. We're missing what action, what system. So what action is action X, but what system is performing the action? What conditions? When? Until when? So this is a very incomplete structure. So in order to help people write requirements and have a complete structure, we can introduce the concept of patterns. So guiding the users into using the right keywords, for example, while introducing a state, then an optional when condition, subject, shall, action, object. So this is the what we call system response in the EARS definition. So after the shall, this is a system response. Before, this is a subject, and each block can be checked to make sure that the subject is appropriate, the action is appropriate, etc. So if we look at requirement level, apart from the syntax, we can check, for example, that we're not missing a unit, we're not missing a tolerance, we're not having any vague content, any open-ended aspect. So in this case, completeness also has is related to accuracy. So if you're using vague content, TBD, TBC, it can be considered a completeness issue because we're missing something, but it's also a lack of accuracy because if you don't have the unit, we cannot probably assess what this means. It's not testable. Same for the tolerance. It's difficult to get to 12 volts without any tolerance defined. And yeah, this is what we have in these different situations. So, and it's not only about the requirement statement, it's also about the attributes, as mentioned before. So you can have a proper syntax and no vague or let's say inaccurate words, but it's also about missing links. So if you have an orphan requirement in your specification, so is the requirement really at the right place? Is it necessary? So we can assess the necessary aspect with the links, with the attributes as well. And the same occurs also with these characteristics. So the same with the completeness of the syntax, which could lead to inaccurate requirements. If we don't have the proper set of attributes here, it could make it difficult to trace, to rank, or to verify. So we need all these information, all these pieces of information in the requirement. So let's check now some examples in the tool. So first use case is writing a requirement based on a pattern. So that's the completeness for an individual requirement. So let's check first this aspect. So I will guide you to the authoring. So for those who are familiar with the doors interface, so this is where the demo is occurring. So we have a rich authoring plugin, so RAT authoring tool in doors, so we can create a new object with this plugin. And then using this plugin, we can select one of the patterns that were pre-configured by the quality manager. So the set of patterns is configured by the back office users, and then the users in the plugin can start writing the requirements. So we start writing the condition, then then we have a list of elements, and while we type down the words, we can see that the drop-down list reduces. You see that we can also use the tab key to select the entry. You can double-click on it as well. After we write the first expression in the condition, which is the state, then we can have another optional condition. For example, the temperature threshold to be considered here in that case for the protective walls. So just to give you some context, this is the temperature warrior. It's competing against other systems to maintain its temperature. And so in that case, we're defining that in the combat mode, so when the competition occurs, what happens if the protective walls temperature is below 65 degrees centigrades. And here we will say that it's a property requirement. So the expected subject is, if I go back a little bit, the expected subject is a set of properties, or we could have the system, because we could have a entity shall have a entity property. So we have different options here, and as long as we're writing, then these options will be reduced to only one. So because I'm introducing a property, then the only option I have in the patterns that I selected is the property. So you can select the specific pattern if you know what to use, or you can let the tool guide you to the right pattern that will be needed in that case. So the power consumption of the heater shall be, so you see that the quality on the right is moving. So we moved from medium quality with some issues here, lack of modal verbs, etc., until we get to the shall verb, which is removing all the issues, because we are starting to write the system response, and we don't have any more conditions, and the condition accepts the use of and, the use of brackets. And so then after we write shall be, we need to express the property. Here we can include optional terms, so we can put the number or have some operators included, maximum of, minimum of, etc. And then we can write the number. So, and after you write this, you see that the tool is guiding you into saying that we're missing the qualifier here. We are missing the unit or the noun qualification. So we need 11 what. That's basically what we're saying here. So this is an incomplete requirement. If we stop here, this is an incomplete requirement, and the tool will give you notice of that. So we need to include the unit. Then if you put a wrong unit, it will be a consistency issue. So telling you that the unit is not accurate. But in that case, we can keep this requirement. Once you click on save and close, this is ready to be used so it's ready to be saved in doors here. And we'll see in the next demo how to assess the quality of the requirements. So that's individual completeness. Make sure that each requirement follows the proper syntax, that all the concepts are involved, and that we answer the WH questions. Second case is we already have a set of requirements written, and what we need to do here is to make sure that we have a set of inputs that we decide to involve in the assessment, and that we have them featured in the requirements. So here in that case, we have 3 metrics checking how many logical functions, how many system functions, how many states are mentioned in the specification. So all these inputs come from the model. So the model can be changing over time, and we can reassess the quality, have automated tasks to assess the quality with the batch process, and have this information updated. So at the beginning, you saw the scoreboard, so you can see the current state and also the evolution. So this could help produce metrics to make sure that you verify properly the requirements. So in that case, we have 3 results. Logical functions, we have a 0.59 score. This means we're lacking 59% of the selected logical functions. So the model we selected, 50% of system functions, and the states we have high quality because the thresholds in the metric was set to 20%. So below 20%, we have a high quality rating here. But that's something that could be customized by the user, but that's what we have right now here in this result. Once we have the result for each metric, we can double click or right click and view quality details, and we can see the rating of the metric. If we click on the red area of the pie chart, we see that we're missing 1 state. If you look closer at the results here, you see that it says term selected but not found is 1, and we found 5, so that's the percentage that we have. So post combat mode is the state that I'm not featuring here. So if I now go to doors, so I'm going to use the same project. That's the same project I was using in the previous clip. So I'm putting my credentials to enter the doors project. I have my module here, and I say, okay, let's add here a very simple example. I have all these states and modes defined. I will need to add another mode. So I can use the authoring tool if I want to be guided by the tool while writing the requirement, to make sure I have a complete syntax, to make sure that I don't introduce any vague or forbidden word. And then I will start typing work requirement. This time I will not be using patterns. I will consider that I have a simple syntax structure here. That's very simple, because I will just write the temperature order shall have a post combat mode. I don't need patterns to be guided in that case. So, and once it's added here, then you can add it below, or you can add it just after. So you have the different options are offered by the plugin. And then you start writing without patterns, and you start being guided by the tool. The only error featured here, the only warning we have is the traceability. So until I didn't put any link here, in link or out link to this requirement, so that's why it's telling me that I still need to have these here. So in terms of completeness, I would be lacking the traceability. But apart from that, I have a correct structure according to the metrics I'm involving here in the tool. Then I can refresh the document, so to make sure I get the last version of the project with what I just wrote, and then we can assess the quality after this gets refreshed. So we refresh the content, we save so the updated version in the repository. So we're saving one new version of the content, and that's the new version that will be assessed in the tool. So we need to go back to the completeness metrics, and then when we assess again the quality, then this rating will go down to 0 because we now have the post-combat mode featured. So in the metric results, we can see the metrics input, and we can also see in which requirements we found each and every input in there. So apart from giving you the fact that it's featured, we also have numbers. So how many occurrences we have of this or that state, which also helps seeing the big picture. Here, what you can see is that in the first pie chart here, we didn't have the completeness, so we had a fairly high quality for the objects. But after we introduced the completeness aspects, and especially these two with low quality, then we see that this is introducing a drop in the quality, because we have, if scroll down a little bit, you see that we have a lack of quality on the completeness side. So the quality, the requirements quality is pretty high, but then in correctness. But once we introduce the completeness aspects, then it's drops down to a total of here it's around 75%. So you can see here 74.89. Okay, so now let's move to the questions to the audience. So Cecilia, do we have any questions?
Yes, we have received a couple of questions. So Elias will answer your questions in a minute. So if you want to comment or ask him anything, please write down your questions in the questions section. While you're writing, I will talk about our next webinar. It's called Systems Requirements Made Easy with AR's Patterns and RAT Authoring Tool. Model-based systems engineering is the current trend in systems engineering projects, but textual requirements are still needed for many reasons. Following an agreed-upon catalog of patterns improves the overall quality of those requirements, reducing dramatically inspection time and affecting important quality characteristics. In this webinar, you will learn about the AR's patterns and how they can be easily implemented on top of your own requirements management tool, thanks to RAT Authoring Tool. RAT can also connect the structure of selected patterns with the information in your models and/or your domain-specific vocabularies, thus boosting even more the consistency of requirements across your documents. The dates for this webinar are the 14th and 16th of May. So over to the questions. During your demo, you mentioned the use of one model as the source of information for the completeness check. Is it possible to have several sources? How is the setting performed?
Okay, so good point. During the demo, I showed so this doors project connected, so that the knowledge base was connected to one model of the temperature warrior. But yeah, you can use the knowledge manager, which is a tool that I was mentioning that contributes to the quality setting of the tools, and especially the inputs that we'll have for the completeness metrics. So you can connect to several models, and then the more models you have, the more extended the information will be, and this will have an impact in the completeness rating. So you could have models of different languages, so SysML or Acadia, Capella, if you have this tool, You can have different sources connected at the same to the same knowledge base and run your assessment. So that's done through the knowledge manager.
Okay.
So I hope that answered the first question.
Yeah. Another question, can the completeness check be filtered to some of the objects, and what are the available options?
Okay, so yeah, that's a good point, because in the examples I was showing, especially the second one, that's a very simple requirement I'm writing, and if you push it further, you could say, okay, I'm just writing the state that I need, and then that's it. It's contributing to the completeness. So yeah, to prevent that from happening, then what you could do is filter the metrics to happen in specific situations. Like you could force the user to define an attribute so that the requirement becomes qualified to belong to the completeness scope. So it's not just I'm creating a draft requirement, a dummy requirement just with the state name, and then this contributes to the completeness, and then that's fine. I can include a filter in the metric to say, okay, I only want to check the requirements that were verified. So usually when we consider the CCC approach, this is a progressive approach. So we don't do CCC all at the same moment. We usually tackle correctness first, because this is where most of the defects occur in the requirements, and that's only after we have a set of correct requirements and consistent requirements that we can check the completeness. But that's usually how we grow the let's say the quality experience in the tool, and so we can use these aspects or the maturity of the requirement to filter the assessment of the completeness.
Okay, thank you, Elias. If you have additional questions or want more information about our tools, don't hesitate to contact us by email directly to Elias or to contact@reusecompany.com. You can also find previous webinars on our website and a lot of videos on our YouTube channel. Thank you very much for attending, and goodbye.
Bye, everyone. Have a nice day.